Hello, everyone. Thank you for joining us for today's Kuringo Tech Tuesday webinar. This session's topic is Monitoring Swarm Object Storage using Prometheus Exporter and Grafana. I'm John Bell, Senior Consultant at Kuringo. Today, I have as our guest System Integrator Abraham Felsenstein, affectionately known as Avi. Avi and I will be available to answer your questions throughout the webinar and at the end of today's presentation. In addition, we have a couple of resources available by the Attachments and Links window on your view screen. If you have any questions after the webinar, you can always reach us by email at info@kuringo.com. And just some quick introductions. Again, I'm John Bell. I've been with Kuringo for over 7 years, and I'm a senior consultant based in Austin, Texas. I specialize in the design, implementation, and management of object storage. I've worked with many of our largest customers to transform their storage infrastructure with highly efficient and cost-effective object storage solutions. Avi, please introduce yourself.
Thank you, John. I've been at Kuringo for 10 years. I started in post-sales support, supporting our file system gateway products, and then I moved on to setting up proof of concepts and evaluating products that have an S3 backend export capability, essentially certifying them for use with our S3 implementation. Currently, I manage our sales demo lab environment in Austin. I am the maintainer of the Swarm Developer Edition that you can download from our Connect website, as well as our single server appliance. Together with our community feedback, I've been really interested in I've been the driving force behind adding support for Prometheus to Swarm, and I'm happy today to be able to present you with some of the first results of this ongoing effort. On to you, John.
Very good. Thank you, Avi. Just some quick bookkeeping before we proceed. A little note about Kuringo. Kuringo was founded in 2005 to change the economics of storage by designing software from the ground up to solve issues associated with relentless data growth. Kuringo's flagship product, Swarm, applications and hardware, providing a foundation for continued data access and analysis that constantly evolves while guaranteeing data integrity. Today, Kuringo software-defined object storage solutions are used to preserve and provide access to rapidly scaling data sets across many industries by organizations such as NEP, Argonne National Labs, UK Science and Technology Facilities Council Scientific Computing Department, Texas Tech University, US Department of Defense, the Brazilian Federal Court System, British Telecom, and hundreds more worldwide. So just a quick rundown of our agenda today. We're going to go through a small number of slides just to give you a foundation for what Avi is going to demonstrate. We're going to do a quick overview of Prometheus and Grafana, along with a top-level architectural overview of what that looks like. We'll discuss the specific exported Swarm metrics that are available with Swarm's Prometheus integration. And then Avi will provide us with a live demo. And if we have any questions left over, we'll go through the appropriate Q&A, and then we'll wrap things up. So Avi, I'm going to put the buttons over to you.
Thank you, John. So Prometheus is an open source system monitoring and alerting toolkit, and it's obviously used by a lot of people around the world. I just want to mention, first of all, that the systems that you use today to monitor our solution stack via SNMP or via the Swarm UI, or even recently we've been storing metrics in Elasticsearch and made that available to you as well. All these still remain in place. We're certainly not going to replace them. We're simply going to expand them further with a new offering, the Prometheus option here. And it's the whole goal today is to introduce you to what we've done here, and these are obviously the first steps in this area. Grafana is a nice open source metric analytics and visualization suite that works very well with it. We've actually been using that in the past few months in relation to looking at how we can visualize the metrics Elasticsearch as a data source. Some of our customers have been interested in looking at it with Kibana for analytics as well. And it's during those efforts that we found out that there are other data sources available. What are their? Do they have anything special? Do they add anything new that we couldn't do with Elasticsearch? And that's where Prometheus caught my eye, and I really liked what we could do with it, and that's why I pushed for integration with it. So let's move on to the next slide, so I can show. Yeah, thank you very much.
Sure.
Thank you. So today, I just want to kind of isolate where the areas are that I'm going to be demonstrating. We're definitely going to talk about the Prometheus server, which is essentially a time series database. We are going to cover Grafana, of course. We're going to cover the various node exporters that are available today, including the ones that we're adding to it. We're not going to cover the push gateway, since we don't really have a need for that right now. And I'm reserving the alert manager and everything to do with alerting for a second webinar at a future date, where we're really going to cover in detail the entire aspect of alerting in general. So today the focus is going to be on Prometheus. It's essentially pulling metrics from a set of the open source node exporters. If you go online, you can find a whole range of open source node exporters. One available is the Elasticsearch node exporter. I've been using that for a few weeks. I really like what's coming out of there. You can use the HA proxy node exporter to expose metrics from the load balancer. There's a generic node exporter for viewing host metrics out of any generic Linux server, and essentially that's what we would use if you wanted to today to measure what's going on a gateway. And we are adding to that today the Swarm node exporter to further expand Swarm-specific metrics that you can't get anywhere else. Grafana is essentially a consumer of those metrics. It's a nice pluggable way to visualize what's going on in your cluster. It's got some nice authentication capabilities. It's essentially a web app that gets served out to your browser. It's nice and fast, and we're going to be showing you off what it can do today. Service discovery in general. So for the purpose of this demo, I'm going to be using static configuration. You can certainly use DNS service discovery, and there's like 13 or 14 other possibilities out there. I'm just not going to go over all of them. That's basically, there's enough information available on Prometheus.io if you wish to understand better how all of that can be configured. Okay, so how do we actually set up and enable Swarm node exporter? So let's go on to the next slide. Okay, thanks. So we've taken the Prometheus node exporter and we've extended it with our own system and chassis level metrics using the text file collector. By default, we've enabled it. As soon as you have Swarm 10.2 and you boot it up, you will see that port 9100 is enabled. That's the node exporter running on it. It will expose via the URI/metrics a Prometheus formatted set of metrics. Those are no different from what you were used to today if you were to install yourself the node exporter. And then if you actually want to expand that further with the Swarm specific metrics, you have to enable that. By default, we have decided not to enable it immediately because some customers don't require this. We recommend an export frequency of 120 seconds. You can put it down as low as 30 seconds, which is the default for Prometheus. It really comes down to how fast you want to see changes. I don't recommend too fast because it's going to consume more disk space on your Prometheus server. So it's really down to your preference as a system administrator. All right, let's move on to the next slide.
Okay.
So for those of you who already know Prometheus node exporter and are curious as to which collectors we decided to enable, here's a small list of what we've enabled by default. Obviously, we need text file for our own uses. That's how we expand it with the Swarm metrics. All the other modules that we disabled, we didn't feel were relevant for our solution stack. If you have any feedback or questions about that, let me know separately, and I will certainly answer those. All right, let's move on to the next slide.
Well, a quick question for you here, Avi.
Sure.
The miminfo_numa one is particularly interesting. Can you elaborate on what we're capturing there?
So we're not capturing ourselves. So the node exporter makes available a whole list of information. In this particular instance, it's going to be more than just free memory, used memory, cache buffer memory, but much deeper. If you have multiple CPU sockets, you're going to want to know a lot more than just a global number at a high level, which is unfortunately what you would get if you were to only look at process information. So these are actually built in already into the open source node exporter.
Mm-hmm.
Where we come and shine with our own swarm metrics is going to be in the text file section, and the next slide is actually going to show you what it is exactly that we decided to expose via Prometheus.
Okay, so move on.
Yeah, please. Thank you. So we've for this first iteration, we've subdivided the metrics into 7 categories. You can see here, basically we're going to allow you to see what's going on with your feeds, indexing or replication type feeds. We're going to allow you to see what's going on with the health processor, what type of objects you've decided to store on the storage nodes, how much memory it's consuming, but more importantly, the type of operations that are going on in your cluster, the type of HTTP response codes that are coming back to your application servers, and of course, capacity-related information about your objects on the various volumes. It's a starting point. We definitely are going to expand this further as we learn what is useful to see and expose. But we've already started to actually add some features that we didn't actually expose before using SNMP or some of our other protocols. All right, so let's move on to the next slide.
Okay.
So if you actually want to enable in your Prometheus server the ability to collect information from the Swarm Prometheus node exporter, you simply have to add a section with a static config in this instance, where you just point to the IP addresses of your various chassis. Port number 9100 is essentially what you would have to point it to. You can use DNS host names, or you can use IP addresses. It's a choice. Just be mindful that during the lifetime of your hardware, it really needs to keep the same name or the same IP, because if you decide to change it later, it is actually going to end up becoming a new time series in Prometheus, and you're not going to have any continuity in your historical charts. So it's be careful and mindful when you first configure this, that you think about, okay, how am I going to reference my nodes? Is it always going to be those names? And so yes, obviously a preference would be to use DNS names if you can. But it's not a big deal in the beginning if you're just evaluating. It's fine to use IP addresses. All right, so let's move on to the next slide. So we have made available a public dashboard that you can download from grafana.com. If you already have a Grafana server running, I have tested Grafana 5 and Grafana 6. If you import a dashboard, it is essentially going to ask you for a dashboard ID. If you just type in 10,255, you will be able to see this. I made sure when I designed this dashboard that it does not rely on any customized panels that you would have to additionally add on top of the native Grafana server. So there's no dependencies. It does require Grafana 5 and above. And from a Prometheus point of view, it does require you to have Prometheus 2.7 or higher. Those are the versions that have been tested. In fact, right now I'm running 2.9.2. And it evolves so fast that you can't keep up with the version numbers. Essentially, that's all you would need. You can go right now and download this if you want. With that, we're going to actually go and move on to the live demo at this point. I think that's the last slide.
And before we do make this link available. If you look in your attachments and links section for the presentation, we make this available so you can pull this up yourself. So let's move on.
Sorry, and also the live demo is done on a machine that we've decided to share with you online on the internet, for which the link is also available in the attachments and links. It's called Kuringo. Let's see, Kuringo
the Kuringo swarm system monitoring.
Kuringo swarm systems monitoring dashboard data, that's right. It will allow you to, it's basically guest access. There's no authentication required, and you'll be able to basically see the exact same thing I'm about to present to you if you're curious. All right, so I'm going to move on to screen share at this point. Okay, this is the part where it's not allowing me. Bear with me.
There should be a button there that says Add BrightTalk Screen Share, Avi.
Yeah, it's not showing up. That's what I was trying. That's what I was afraid of earlier. Yeah, it's not showing up. So I may have to, I guess, re-log in to the BrightTalk presenter screen. It's just not showing, presenting me with the option to share my screen at this point. I will attempt at the same time as I'm logged in, see if it's I'm able to get through it. Sorry about that, folks.
Technical difficulties, bear with us.
I'm just going to try and log in from another.
So you're not given an option to add BrightTalk Screen Share when you click on the Screen Share button?
That's correct. That's why I'm trying to log out and log in again, just to see if that...
It should be right under your slides. Are you not seeing that?
I'm seeing the button, but when I click on it, it's not giving me the option to... oh, now it does. So like I said, I just need to log in again.
Yeah,
no worries.
Should have been there.
The issue should have been resolved in a moment. And I'm sharing my entire screen now. And let me know if you're able to see. 1 second. I have to actually select it. All right. Let me know if you're able to see my screen.
Yeah,
working for you?
It's fine.
All right. So, sorry, folks. All right. So, I'm currently I have a tree chassis swarm cluster running in our swarm demo environment in Austin. This is made out of Supermicro Twin Pro blades with 64 gigs of RAM and 6 1 terabyte volumes each. And this is a shared resource that is being used by our employees to evaluate products. I have currently a few FileFly servers, some SwarmNFS servers, and various other applications pointed at it, and they're continuously generating loads. So it's a good shared cluster to try out our dashboard against and see what we're going to see with our demo dashboard. If I actually drill down, yesterday I retired a drive for the demo purposes. As you can see here, this is going to show up in the board that I'm about to show you. Just wanted to point out that this has all been set up for this environment. So if I move on to the actual dashboard itself, once you've downloaded it, the first thing you want to make sure is that you're running Swarm 10.2. That's absolutely required for this to work. You want to make sure that you select a good time range at the top right corner. I have selected 7 days for now, and I'll be switching between various time range depending on the use case I want to show you. And really, this is my first attempt at making a public dashboard. Obviously, it's not an exhaustive list of all the potential metrics that we've decided to share with you, but it's a good first attempt at it. I welcome feedback on it, of course. It's kind of divided into 2 sections. The first section is just a quick overview of the health of your cluster. In this situation, the first thing I want to know is how many chassis do I have? 3. How many volumes do I have? How many am I consuming the capacity I expected it to consume? How many objects do I have, and how much load is there currently running against this cluster? So right now there is 6,820 operations per second being pushed against this cluster from various application servers. And if I really want to know what type of operations are going on, I have a quick swarm operations overview. That's a moment in time snapshot of right now. The operations are composed mostly of get operations, so read operations. There is some writing going on as well. That's the red bar puts that you see over here. So that it gives you a quick overview of whether someone's writing, deleting. Doesn't tell you how it's divided yet, subdivided further into your chassis, but we're going to get to that. But it's a good way to know whether the workload is read heavy, write heavy, or a mixed workload at this point. The other thing you want to know as an administrator the first time you go in is quickly know whether your search cluster is healthy. Since this is where we store our metadata, you want to know whether their connectivity to it is not interrupted by in any way, not blocked in any way. So that's why you have the swarm indexing feeds view. This is a list of feed status information from each chassis perspective. If you had a bigger cluster, I only have 3 chassis myself, but if you had 10 chassis or 20, you obviously would see 20 lines in that table, and it would have a scroll bar, of course. Further than that, a quick overview of the network bandwidth being consumed right now cluster-wide. So network inbound and outbound. Those are all things you're used to see today with the generic node exporter from Prometheus, since it's coming straight out of the network I/O statistics. There is some temperature information about the chassis, which is exposed through the sensor, the hardware sensors, and of course some CPU load information on how busy my nodes are right now. So this is just an overview of the state, but I think the real interesting parts are historical overview on what's going on in your cluster. For me personally, that's the more interesting parts. And all of this is really a basis to start to evaluate the workloads of your cluster and start to identify maybe you should define some thresholds for certain events that are going on that you wish to be alerted for. And if the CPU is too high, or if there are too many operations going on of a certain type, or too many errors going on, you want to be alerted for all of this. So every single one of those are metrics that can be alerted on. And we're going to take this opportunity to learn what is a good metric to build an alert on top, and we're going to share that with our customers as well, of course. As we go down, now we're starting to really delve into the details of what it is that we decided to expose with swarm metrics. So for the first time, we're able to distinguish between operations that are coming in from your application servers, what I call here client operations, and operations that are happening between the chassis, inter-node operations or inter-chassis operations if you prefer. For instance, if a node is trying to protect your data and make a copy across from one chassis to another, we consider that to be an inter-node operation. You want to see that separately from what's going on between the cluster and your application servers. So in green on this chart here, you see the client-side operations that are going on right now. It's got this weird sinus effect that's going on. That's because I have an application server that is continuously scanning a list of objects and determining whether or not some of them need to be deleted. The same amount of work needs to be done periodically. That's why it's so nice and going up and down at the same heights. And a certain performance is expected when I do those operations. Over the weekend, I decided to retire a drive to simulate a drive failure. That's what you see happening right about here. Essentially what happens then is the chassis become active and start to protect the data again. They start to copy data around between the chassis, and that happens for a short period of time. And it's interesting to see that while that's happening and there's increased loads going on, it does not affect whatsoever the performance of my clients. They still see the exact same performance. Those lines don't go down, and that's interesting to see here.
So a quick question: Are you doing the capability where you can get the cursor to snap to both graphs? What's the name of that capability again?
Right, crosshair. That's correct. So if you set up a dashboard, one of the settings that you can choose is shared crosshair. Essentially, it's very hard to see on this color scheme, but there's a red line going across the chart. this is where the crosshair is essentially, and as you move that left or right, it synchronizes with a same red line on the other chart, so that you can see the event that's going on in one chart. How does it synchronize and match up with an event in another chart? Because often these charts don't align. As you can see here, the text and the legend never is as long, so it's very hard to build charts that align with each other. You can certainly opt to put all your legends below your charts. It just consumes more valuable screen space. So I prefer to put the legend on the right, but that's a question of preference. But yes, shared crosshair is definitely enabled, and it's very easy to then see what effects a certain event had at a certain time. In fact, you can even add annotations, I believe. It will leave behind like a little annotation that says something happened here, and it will show up on every single chart.
Oh, very nifty. So if you're an operator and you're trying to correlate different events within the charts, you're able to do that.
Absolutely. And I'm about to show that as I show you the next use case where you will see where that comes useful. And that's the next explanation in a moment. But so one of the things I see myself is I don't want to just see how much load is coming in against my cluster. I actually want to see whether every one of my chassis is contributing fairly and equally the same amount of work. That's what the next chart is for, is to just show you those operations that are happening, those client-side operations, how is that divided across the three chassis? And as you can see here, they're equally doing the same amount of work, but that's not always going to be the case. To give you an example, last week I had an outage. If I move over my time range to 30 days, we're going to be able to see some other drive failures that we've had a week ago. So here's a double drive failure. And it's not always going to be that the effects of that is going to, so this is a very nice example where you can see where it starts, and at the same time in the chart that shows the load distribution across the three chassis, the chassis that is actually doing the retiring of the drives is so busy that it's not actually taking on any client operations. And that's fine. The way that Swarm has been designed is that they're going to bid, and the other chassis are simply going to pick up more work amongst themselves. And at the end of the day, the overall load from the client perspective is going to be the performance is going to be exactly the same. This is a stacked view. So from a customer perspective, at all times, there was 800 operations per second going on, and it didn't see a slowdown because one of the chassis decided to be very busy with the retiring of a drive. And that's a perfect example of how you can visualize this.
Say, Avi, is there a chart available that lets you see the bidding values?
There is. I just didn't add it to this particular dashboard, but we have certainly exposed bid, the write bid, the read bid, and the replication bid. Those statistics have been exposed through the Swarm Prometheus node exporter, and you definitely can. You can definitely chart those and see the effects. I just didn't add it in this particular. This is a beginner dashboard for people who are probably maybe seeing Swarm for the first time. I'm planning on making a more advanced one, I would say, for experts and veterans. And I would definitely, the write bid and the read bid would be my choice for adding to the advanced dashboard.
So a follow-up question. Even though the chart's not there, the data is still being gathered. Is that correct?
The data is being gathered and it is being stored, and I can prove it. Let's see. There should be. Yeah. So Grafana 6 has added the Explore option. This is not something that happened before. You can essentially simply go to it and type in to query your data source. So we can type in our metrics data store. And let me see if, actually you can just type in write bit, and it's going to, oops, I just need to learn what we called it. Was it bit? There you go. So metrics volume underscore write bit, rep bit, and read bit are definitely metrics that exposed. You'd have to kind of pick, of course, a specific chassis. So let's just take one. Instance is 10. So this is a really nice way to explore what we have, to very quickly visualize what it's got to offer. And I think you further need to say if there's a specific volume you are interested in, although that doesn't matter for the write bit, I think. Let's see. Actually, on the legend, you can simply say you want to see one over the other. So let's just pick one that's a bit interesting. Here you go. So this is the right bit for a single drive SDC out of the 8 drives that I have available. That just goes up and down depending on what's going on in the cluster. But yeah, here. So yes, the answer is it's there, it's available, it's collected. It's just up to you to decide whether you want to chart and show it in your dashboard. All right.
Very nice.
Let's go back to it. Just make sure I'm setting this up correctly. Okay. So a lot of you are probably going to wonder, okay, that's great, that's very nice, but I'm not so interested in what's going on in globally or divided over the chassis, but I actually want to know what type of operations are going on. And so yes, you can absolutely plot that. Here's a good example of how you can plot the actual operations. So is there a lot of gets going on? Maybe you're not interested in gets. You just want to know whether there's a lot of puts going on or a lot of posts going on. So I started an application today that is doing a lot of those. And so yes, you can definitely focus on just a specific operation and see whether those are going on. Grafana allows you to select a specific part of a legend, and it will only show you that one. If you click on it again, it will show you the entire list. And more importantly, I think a lot of you are going to be interested in knowing that you can see the type of response codes coming back. I think you would definitely want to be alerted if you had a spike of 404s, file not found, object not found actually, or 503, which would be server busy, 507, which would be out of space. These kind of response codes you definitely want to be alerted on. For simplicity's sake, I really collapsed them so that it's a little bit easier to see the good codes from the bad codes, 2XX, 3XX, 5XX, but really we've actually produced a counter for every single response code. So you'll be able to isolate very specific use cases for your needs. So in my situation here, if we zoom back to, let's see, I think it was 7 days. Okay, and if we zoom in here on that spike over here, so here's an example of, I had a misconfigured application and it was producing a spike of 404 errors. When I rectified it, it eventually ended up doing what I expected it to do, which was a bunch of deletes, which I see here happen finally. And that's kind of what I wanted to see. So it's not going to tell you which application, but it is going to tell you that there is someone out there who's doing a whole lot of 404s. If you actually want to drill down further and understand more about, okay, but who's doing this? Where is this coming from? At that point, obviously, you need the audit logs from the content gateway, or you actually need to start looking at the logs. Now, one thing I've seen is Prometheus is working hard at starting to add logging inside Grafana, which is interesting. They're starting to think of more like Graylog, where they want to combine being able to see logging that is stored in Elasticsearch together with metrics events, and then combine the two together, which I think would be an interesting concept. But we're not there yet. It's in early days right now, but it's a good starting. I think it's a good evolution. Right now, at least you'll be able to detect spikes, set the threshold, and get an alert for these kinds of issues. That would be actually quite useful, I think. All right, let me go back to the 7 days view. Another thing that, sorry?
For those in the audience, just to reiterate a point here, what Avi's demonstrating here is that you have the capability to profile what is going on in your particular cluster. You may hear us say from time to time that each cluster is a little bit different in its behavior depending on the data driving characteristics of the client activity. And these tools allow you to basically profile what is a baseline or normal, over a period of time. And then once you know what that is, you can set some intelligent thresholds for alerting so that you're not constantly being alerted on something that really isn't a problem. You won't be suffering from alarm fatigue. You can actually profile what is normal in your cluster versus what is not normal.
Yeah, and to reiterate, obviously I'm not showing an exhaustive list of all the possible metrics that we have. One of the things that you may be interested is that if you have a replication feed, you'll be able to plot how many items are pending in the queue, So is that evolving over time, or is it blocked and flat? And those kinds of things you'll be able to see an alert on.
Yeah, we get that one a lot. The insights into replication feed is very important.
Agreed. If you have a sidebar failure, so a few weeks ago in Austin there was a storm. If I change my view to 90 days, you're going to see that the effects on that, I think most of you who have already used Prometheus, it's going to be essentially a hole in your graph. There's just no data. It happened on the Friday. We only noticed it on the Monday. So, I mean, that shouldn't be a scenario you haven't heard before, where it took a couple of days to get everything back and running, including the actual monitoring server service itself, which was in the same lab. So, yeah, everything went down. Happens. This is the effects when that happens. It's a choice whether or not you're going to see it to be like empty like this, like nulls and zeros, or whether you want the lines to connect. That's a configuration choice. I decided to make it 0 because it's easier to understand what happened here.
So a quick question, Avi. This is kind of an interesting scenario because how would you alert? We may be getting ahead of ourselves with the alerting webinar, but how would you set up an alert for a situation like this?
That's a good question. So Prometheus themselves basically say that you need like a canary in a coal type situation where you're sending a heartbeat from Prometheus server to an external party, third party, and if that heartbeat doesn't come in, that external party sends you a pager. Essentially, there's lots of services like that on the internet. You essentially configure it one time. Prometheus server sends out a heartbeat, and if it doesn't come in, you get an email. That's how you detect these kinds of issues. Otherwise, you have to put your monitoring system on a separate power group, completely separate, so that if the entire, if the site goes down, it's not affected. But that's not always what people are going to do, unfortunately.
So it's interesting. You either have to isolate its power, or you have to go out of band with a third-party service. Interesting.
With a third-party service that will basically just serve as a way to notify you that a heartbeat from your system didn't come in, essentially. And it doesn't need to be external. I mean, it can be a service that you have within your company. I'm just saying that it shouldn't just run on the same power group. That's all.
Makes sense.
All right, so I'm going to go back to the 7-day view here for a moment, just to continue down. Another thing you can certainly do, and that didn't require our Swarm integration. That's something that you already got from the node exporter, but you can certainly see the cluster-wide network bandwidth coming in and the disk reads and disk writes. That is exposed by us since we are extending the Prometheus node exporter. But it's interesting to see that there is sometimes disk activity going on your nodes, on your storage nodes that are not matching, don't have a matching network activity. And now to give you a very simple example, we have a health processor that runs in the background continuously, and it's checking the integrity of your data. And so these spikes that you see on a regular basis in my situation, it's happening every few days. This is the health processor double checking my data to make sure that it's fine, that the integrity matches. Sometimes it's actually going to be retiring a drive, and that always has a matching network activity. If I zoom in on this one, this is where I was retiring a drive. I have both disk activity and network activity going on at the same time. So that would definitely be a drive retire going on here. Finally, we've had customers ask us, hey, we'd like to visualize multicast traffic in your cluster. We're worried that it might be consuming a lot of bandwidth and it's hammering our switches. And so, yes, you can view multicast traffic now from a Swarm storage nodes perspective. We'll expose that. If I zoom out a little bit higher on 30 days here, just to give you a reference, this particular cluster used to produce about 1,500 packets per second in multicast traffic. And that's because in the past, when you wanted to find out where an object was, you needed to do a multicast query to find that out. That's an expensive thing to do in a network environment. I believe in Swarm 8, we introduced the concept of an overlay index. For those of you who don't know what that is, it's simply we use some of your free memory available on the storage nodes to keep an index of hints of where other objects are located on other chassis. And so if a query comes in saying, hey, do you have this object? We simply need to do a memory lookup. instead of having to do a multicast query, and that significantly reduces the time it takes to get back a response on an object that maybe you're doing on purpose. You're doing a checkup to see if an object already exists before you decide to actually store it on Swarm. These kinds of things used to be quite expensive to do, but now it's quite fast because we have an in-memory index. And so you can see that over here now, it's on the right side. Sorry, that's a bit confusing, but on the right side, that's the axis for the multicast traffic. The reason you see a left axis is because I have some hidden metrics that I disabled, which are showing UDP traffic. You can turn those back on if you're curious. But right now I'm only showing you multicast traffic, and essentially it's about 20 or 30 when it's idle, and when it's busy, about 100 or so, 150 packets per second is the multicast traffic. We still have a few services that are using it. We're trying to reduce that down to the most, but this is a far cry from what we used to have, which was 1500 packets per second. And the bigger your cluster, the higher this is going to be. So it will be interesting to visualize this on some real customer environments.
Is overlay enabled in this particular cluster when
you're
looking at the chart?
Absolutely. Yeah. Even on a small cluster like this one, which only has 3 chassis, if you have free memory, I highly advise you to enable the overlay index. It makes an enormous difference for looking up objects that don't exist. Essentially, if you're trying to do a quick check, do I already have this, and then write your data, some applications require this kind of behavior, especially file system gateways that follow the POSIX way of doing things. Yes, sometimes you just can't get around that a file system wants to check first, do you have this, and then write your data.
Mm-hmm. So I think the key takeaway on this one is that this ability to integrate with Prometheus and Grafana and visualize the data allows you to do things like see the before and after impact of making a configuration change.
Yep.
In this example, it would be you'd be able to look at the before and after impact of enabling the overlay index in your cluster, and it would be measured by the change in multicast traffic level.
Right. That's right, and here's another example. My application service only started on the 6th of June. Before that, there was a moment where we were not quite doing a lot of work against the cluster. So you can clearly see there's quite a big change in load going on this particular cluster.
So it's not just for monitoring and alerting, but it can also be for profiling. You could put this in a dev or test environment and perhaps profile the impact of a client integration change and see what's good and bad about it. So it's very powerful in that respect as well.
That's correct. Now I do want to warn that Prometheus themselves, they do say that it's not meant to be used as a performance evaluation tool. It's not fast enough for that purpose.
Oh, I see. Okay.
So just be aware that although yes, you can view workloads, you can't go fine-grained and really start doing performance evaluations with this. Some people might do it. I wouldn't. I think the problem really starts to be an issue when you scale up and you get bigger and bigger clusters with more and more chassis. Then you start to see some of the issues that are going to come up with that. If you're going to use it for performance reasons, I mean, of course. Huh? The other thing I also want to remind people is it's not meant to be a billing system either. So it's not going to tell you any information about billing whatsoever. Okay. So, I mean, if there are any other questions, I just want to let you guys know that to use this, the first one is if you are a developer and you just want to play around with this feature and you don't have time to, or you don't have a Grafana server, you don't have a Prometheus server, you just want to learn this, you can download our Swarm Developer Edition from Connect website. It's an all-in OVA template with 3 VMs. It consumes about 8 gigs of RAM total, so it's designed to run on your laptop essentially. It gives you the entire solution stack that we have to offer for Kuringo, and it comes with Prometheus and Grafana built-in, configured, up and running as soon as you start up the entire VM. You do need to actually download the public dashboard. In the next release, I'll make sure it's added, but it's not yet in there. So if you actually want to see this particular dashboard, you'll have to just import it into the Grafana server. If you need assistance with that, don't be shy and ask us for help. We will always help with that. The other options that we have is if you are an existing customer who already has a Grafana server and a Prometheus server, and you just want to try this out in your environment, you need Swarm 10.2. So in your dev environment, you may already have that. If you do, great. In that case, you just need to download the dashboard. And again, if you have issues with configuring Prometheus for it, or you have problems with the dashboard, let us know. We'll help you with that. Finally, if you don't have time to set up Grafana or Prometheus, but you do have a Swarm cluster and you want assistance with setting up a monitoring solution to try this out, we actually have a Swarm telemetry OVA package. It's a single VM with Prometheus and Grafana built in. There's a small install guide because you need to tell it which chassis you want to monitor. It's like a one-pager, I think, or two, and it will set that up very quickly on a single VM, essentially. Again, if you need assistance with that, we can help you with that. But I expect that if people want to try this out during a proof of concept or against their existing clusters, these options are definitely available for you. So here, with that, if there are any other questions that you want me to go over certain things.
There is actually a question from the audience,
yeah, sure.
and okay. It rolls back to the discussion around alerting. And the question is, can you acknowledge an alert in Prometheus or on Prometheus?
That's a very good question. So this is why I wanted to make a separate advanced webinar, because there's a distinction. So there's two ways of setting up alerts. Grafana themselves has a capability to actually add alerts to panels. I don't recommend that route, and I'll explain why in the advanced webinar. And then Prometheus themselves has it as well. They have an API for that. So the API allows you to, there's a prompt tool, which is a Golang application that allows you to query the state of your alerts, and it allows you to send acknowledgements, like you say, but that's a command line approach. If you wish, you can visualize your alerts in Grafana, so you can see that they're there. As far as to acknowledging, that's a very good question. Whether you can do it from within Grafana, I would have to investigate. Whether you can do it from within Prometheus, there is a Prometheus UI. Let me just quickly go to it for a second. So I'm just going to go to one of my Prometheus servers. That would be 9090. Oops, 248, sorry, wrong IP address. So if you go to the Prometheus, it has an alert section. I don't have any alerts configured, but this is where you would see the state of your alerts, and this is where you would acknowledge them. But I believe that the question of the others is whether you could do it from within Grafana, or did I misunderstood that part?
Can you acknowledge an alert on Prometheus itself?
Yeah, I think so, yes. I think so, yes. I just don't have one that's running where I can point you to it. I can try another one just to see if it has alerts defined. I think this one does, because we're experimenting. So there is an example of not phoning home. Mm-hmm. No, so that one is just what the state of the alerts are. I don't see any ways to actually acknowledge the actual alerts themselves. Not from here, no. No. So let me investigate that, and I'll get back to the person who asked the question. Make sure to leave us your details so we can get back to you. We'll have to investigate that part. But I'll be covering that in the next webinar about alerting in general. All right, let me go back to, sorry.
Yeah, I figured that'd be a topic for the next webinar, but
yeah, I think because it ties into many things, and you'd have to really start covering the entire area. It's hard to just quickly pinpoint on that and talk about it.
and I think another takeaway for our folks in the audience is we've put a lot of work, and Avi in particular has put a lot of work into getting Prometheus and Grafana to this point that you see here. The actual quote unquote supported product itself is basically just the Swarm integration. Those, if you go back and look at the slides and the settings that you need to enable in a 10.2 cluster, that's really the supported piece. The things that Avi is outlining, all this work that he's done here is not actually shipping product. You know, it's available in the demo bundle, things of that nature, but the actual shipping product is just those configuration lines for the Swarm cluster itself.
Yeah, I was going to show that through the Swarm UI, it's probably an advanced setting, is my guess. Through the Swarm UI, I believe that you can actually set the metrics. Just trying to look for it. Okay, not this one. Okay, never mind. Probably didn't install it yet. Okay, sorry about that.
I think that's the other thing to bring to their attention is that it's not a dynamic setting, Avi.
That's right. Not yet.
You have to put it in the cluster config, and you have to restart the cluster for it to take effect, and that's why it doesn't show up in Swarm UI. It's not dynamic. Yeah.
We're working on it. Next release, we'll have it there. The goal is to have it available in the UI, of course.
Mm-hmm.
Absolutely.
Okay, very good. That's all the questions we had from the audience, Avi.
Okay, very good. So I plan on creating other dashboards in the future. Then this is just our first attempt at this. We'll share them through Grafana.com as well. At least the demo example ones. I plan at least one more advanced one so that we can cover some of the other interesting swarm metrics rather than just the introductory basic ones that we saw here. And then, I guess look out for developments around that area. This is really an exciting time for us. We're really happy that we can finally make some progress on how you can monitor and alert around our solution stack. I guess at this point, let's wrap up.
Okay.
And thank you for everybody's time.
Yeah. Yes, thank you, Avi. And thanks everyone for joining us today. To keep up with Kuringo, follow us on Twitter, LinkedIn, or Facebook. If you have additional questions or would like to schedule a custom demo, please email us at info@kuringo.com. We'd also like to take this opportunity to invite you to join us next week, where myself and Director of Marketing, Sarah Cook, provide a webinar on using Elasticsearch with object storage on July 16th. With that said, I hope everybody enjoys your day, and thank you again for joining us on this webinar. Bye-bye.
All right.